to get started. We'll get some intros out of the way. We'll get some rules of the road out of the way. I don't know why I keep coming up with these road metaphors. I'm going to share my screen. Okay, can you guys see my screen? Thumbs up?
Yes.
Excellent.
Thumbs up.
Okay, great. So, guys, welcome to the Security and Compliance Immersion Day. Thank you for coming. I think this is going to be a really informative session. We've all been on Zoom enough, I think, in the last year to know how this works, right? If you know how to mute and unmute yourself, you're doing well. I am going to leave you guys as participants in this meeting who can unmute and mute yourselves at any time. So if you have a question, you want to raise your hand and ask a question while we're talking, feel free to interrupt us or hold your questions to the end of each segment. That's fine too. If you would rather ask a typewritten question, you can do so in the Q&A section of Zoom. If you're having audio issues, you can email Chrissy or just type a question in the Q&A portion and we'll help you figure it out. If you don't hear me talking right now, you have an audio issue, so reach out to Chrissy. Please mute your mic if you're not talking, or else we'll just mute you for you so we don't disturb other participants. As I said at the beginning, if you didn't hear me, we're going to try to make this as interactive as possible, right? Because this is a 3-hour session, right? There will be plenty of breaks. We'll have spots for you to, go get coffee or stand up and walk around and stuff like that. But we all know Zoom meetings, especially long Zoom meetings, it can be hard to maintain attention for the full time span. So that's why we're trying to make it interactive. If you, like I said, if you want to break in and ask us any questions, that'll help make that a more interactive and hopefully useful session for you guys. Introduction. So my name is Lindsay Syhakhom. I'm a solutions architect at Logicworks. I've been here about 6 years. My day job is essentially, I talk to companies who are trying to plan for migration, or maybe they've already migrated and they're experiencing some account chaos, or they're just trying to get their feet under them in terms of security and compliance. That's kind of what I do day to day. I had previously worked at startups, nonprofits, a health insurance company, mostly in product roles and now in solutions architecture. And just a little side bit about me, I'm a rock climber. I also foster cats. I feel like those two things go together somehow. So over to you, Donovan.
Yeah, thanks, Lindsay. Hey, everybody. Thank you for joining us today. My name is Donovan Brady. I am the Director of Solutions Architecture here at Logicworks. I, too, have been at the company for about almost 7 years now. It has been a wild ride, and I've enjoyed every moment of it. I have a background in back-end software engineering. I actually helped design and build Logicworks' cloud automation platform, our cloud management platform. That includes our customer portal, the automation tools on the back end, our monitoring systems, and infrastructure as code deployments. Similar to Lindsay, I work on the front end with customers, helping to design and consult on, how we're going to do this migration. How do we optimize? We're already in the cloud. What should we do now? Perform assessments, make sure that our customers are in their best posture to succeed while managing their infrastructure, right? Fun fact about me, I am a musician, and it is pretty much every aspect of my life. You will never catch me not singing, dancing, humming, whistling. There's always a song in my head, and people make fun of me about it all the time. I'm also an avid Harry Potter fan, as you can see the Gryffindor scarf in the background over there. Lindsay is as well. We actually started a Harry Potter book club during the pandemic at Logicworks. I'm the reigning 2-time trivia champion. Lindsay nipping.
Really trying to rub that in. So, okay.
Yeah.
Cool.
All right.
And you grew a pandemic beard. Very important.
I did,
just in case people don't recognize the picture. Yeah. Okay.
Yeah.
Cool. Okay, a little bit about Logicworks. So Logicworks, we've been around for more than 25 years. We're an AWS Premier Consulting Partner, which is essentially the highest tier of consulting partner that you can be. We have lots of competencies where we participate in dozens of kind of partner programs. We're also a leader in the Gartner Magic Quadrant for public cloud infrastructure, professional and managed services, which is a mouthful to say, but essentially means, we're alongside companies that are, 100 times Logicworks' size, but we have the technical chops and tooling to kind of be on par with those companies. We're headquartered in New York, but we have offices all over: Seattle, Houston, Denver, Boston. We are HIPAA, High Trust, PCI, SOC 1, SOC 2, and ISO 27001 certified. So we undergo 6 annual compliance audits, hence the reason why we're hosting this security and compliance immersion day today and have the chops to talk about it. So this is something that we go through ourselves, we help our customers go through. It's kind of, we tend to, as Logicworks, attract highly regulated companies. So healthcare, fintech, SaaS tends to be our core company base. So what do? We basically, like Donovan and I have said, we help companies migrate to the cloud. We help them manage the cloud. So we offer 24/7 managed services with our NOC team. And we also help people automate the cloud, in infrastructure as code, DevSecOps. We'll get into that a little bit today. And also, meet their security and compliance obligations. So that's a little bit about Logicworks. Again, we have the AWS security competency, which is what qualifies us to perform this immersion day today. And the security competency is broken into 2 sort of key sections: the security engineering and security operations and automation. And we qualified for both sections. Okay, so just a heads up, after this immersion day is complete, basically for the rest of the day after 2 p.m., me and Donovan are available to talk to you one-on-one for anything, any questions that come up during this immersion day. You don't need to ask us about Logicworks. It can literally be like, what do I do about this problem I'm coming up against? We're happy to talk to you. That's part of the immersion day. So if you want to have a one-on-one session with us after this webinar, feel free to put it in the chat, email one of us, put my email address in the chat, and we can set that up. Okay, so here's the poll. So you should see in front of your screen right now a set of poll questions that basically ask you, how experienced are you with AWS? What kind of work do you do? Where is your organization today in terms of security and compliance? So if you guys could just, does everyone see that polling? Donovan, do you see it? You do? Cool.
Yep.
You guys could just answer those poll questions. That'd be really helpful. I'll give you a few minutes to do that. Great. See those poll questions coming in. I'll give you a few minutes to answer. Excellent. Looks like just the last couple are coming in. Okay, cool. Looks like everyone's voted but me and Donna. We're not going to vote. So I'm going to end that, and I'm going to share the results with you guys. So as you can see, we kept this anonymous. So even though I'm sharing results, we can't see your guys' names. So no worries there. But it looks like most people have kind of there's a widespread on experience in AWS in this group. Some people are kind of right at the beginning of their cloud journey. Some people have dabbled. Most people, it looks like the majority of you use AWS regularly. So that's good, because this is a kind of, we span the gamut a little bit. We talk a little bit about 100 level stuff, but we really quickly get into the 200 and 300 level stuff. So I think that'll be good for you guys. Looks like most of you are engineers. Some of you are other. Then we've got compliance frameworks, a lot of SOC 2 in the audience. Great. So I actually have a a dedicated section about SOC 2 in this immersion day. We'll talk about that at length. I also have a lot of info on PCI and HIPAA in this immersion day. So that really aligns, I think, with what we're going to talk about today. And then where we are in terms of security and compliance maturity, looks like most of you are huddling around the doing okay, not completely mature, or at least a mature security posture, but trying to get to that Fort Knox level, it looks like. So I think that pretty much aligns with what we're going to be talking about today. Some of the people who regularly pass audits and have a mature security posture, you may find that some of the intro sessions where we go through what are the building blocks of security in AWS, what should you really, really not be doing? You may find that you've already checked a lot of those boxes, and that's fine. Maybe you want to join us for the more advanced sessions, but cool. That's helpful. Thanks for answering that, guys. Back control. Okay, so here's our agenda today. So we're going to start, me and Donovan are going to start in security foundations, patterns, and anti-patterns. So we're not just going to give you a high-level overview presentation of security in AWS. We're actually going to show you, here are things in the console and in architecture diagrams that you should be doing and you should not be doing, so that you can really take that as actionable advice and go into your own AWS console and see, do I have this enabled? Do I not have this enabled, et cetera. Then we're going to get into best practices and deployment structures. This is Donovan's going to present this. It's essentially, we're going to go through two users, Alice and Bill, and we're going to see what is Alice doing right and Bill doing wrong, and how can we make Bill more like Alice. Then we're going to have a Q&A session and then a break. So you guys have, you can eat lunch at any point. I don't know what time zone you guys are in, but eat lunch at any point, but we have a break scheduled in. Probably at the end of each session, we'll have, a good 60 seconds to 2 minutes to kind of stand up and walk around. Then I'm going to go into from 1 to 1:45, all about compliance. So compliance automation, some security automation stuff in there too. And then we'll do another Q&A session on that part, and then the breakout sessions as I discussed. So that's our agenda for today. If you have to hop in and out, that's what we're planning on doing. If we get through some of these things faster, great. If we push forward, we don't have a lot of questions and we can end this day early, all the best for all of us. But that's kind of our plan, at least. So after this immersion day, you should be able to lay the foundation for a secure AWS environment, know what you're doing right and wrong, essentially, in a lot of cases. Know critical security patterns and anti-patterns, I've already said. Architect a multi-account environment. So this is going to be a section that Donovan goes into in depth with AWS Control Tower, and start or advance your AWS compliance program. So it sounds like a lot of you already have to meet these compliance frameworks. So how can you mature and advance where you are in compliance? And after this day, there are a couple of things you can do. One, of course, you could take this information you learn, go off and do it yourself. You could also engage Logicworks for a well-architected review, which is essentially a review of best practices on AWS. This is free for most customers. Just contact us if you want to learn more. I'll go into this a little more at the end. And then if you're already on AWS, or if you're rather the opposite, if you're new to the cloud and haven't actually architected, so those people, I think there were 3 of you who have not yet kind of dabbled in AWS, or you just barely dabbled, and you're kind of thinking about the migration to the cloud, we can obviously help you with the migration readiness assessment. So that would be basically a discussion between your team and a solutions architect like me and Donovan, where we analyze your organization's strengths, talk about where you are, talk about your people, your governance, your security requirements, and make a plan, start making a plan for migration. That's also free, for qualified customers. So again, if you want a free one-on-one session with us today from 2 to 4, just put it in the chat and we'll set it up for you. So that's the end of the intro deck. I'm going to now just stop sharing briefly, pull up that security foundations deck, and then we'll be good to go. I'm also going to, while I'm here, I'm just going to Sorry, I asked somebody to unmute accidentally. I'm just going to allow to talk the rest of the people who joined while I was doing the intro. Again, if you guys missed it, you're allowed to unmute yourself and ask a question at any time. I've given you permission in Zoom to talk anytime. So, okay, I'm just going to pull up this deck. And Donovan can get started.
You read my mind. I was going to say, Lindsay, there's some new people that joined. Can you give them
give them the
talking
spiel?
permissions?
Yeah.
And you did it.
Okay. Can you see my screen, Donovan?
Yes, I can. All
Excellent.
right. Perfectamundo.
Let's you get started.
Thank you. All right. So as we just mentioned, today is all about security on AWS. And one of the things that Lindsay had just mentioned is the well-architected framework, right? Well-architected framework centers around 5 core pillars or tenets of maintaining a well-defined environment in AWS. Most customers are pretty much only concerned about the security pillar. So that's what we're going to be talking about today. I wanted to start by talking about the shared responsibility model. Logicworks knows the shared responsibility model very intimately because as a managed services provider, our whole job is to shift some of that additional security, or sorry, not security, responsibility away from our customers and onto us, so that it is really like a seamless transition. But in the shared responsibility model in AWS or in the cloud in general, the cloud provider, AWS, is responsible for the security of the infrastructure, of the hardware. So all of the data centers that AWS owns, they are maintaining the actual security there. They're maintaining security of the services themselves, like the actual service of EC2, right? For example, or S3. That's why we have tools like AWS Shield that are permitted for all customers. But then the customer is responsible for everything else. So as soon as you start deploying any resource on AWS, you are responsible for the security of those resources, be it an EC2 instance, an S3 bucket, a database, block storage, your user permissions, all of that is completely up to you for your security. And I actually like the analogy of a fortress versus a city, right? So when you're thinking about traditional on-premises security, it's pretty much a fortress, right? You've got your locked down data center. You can look at that as Fort Knox and think, well, that's my data center right there. I've got airplanes flying over it, ready to just do anything that's necessary. We've got sentries. We've got our DMZs in the data center, right? We've got everything locked down. We've got our firewalls. Everything is set up and deployed however we want, and we have control over every single portion of it, right? If you look at the shared responsibility model for the on-premises, it pretty much mimics that, right? You are responsible for every single piece of your infrastructure from the bottom, the hardware, the land literally itself, all the way up to your own data. In the cloud, it's a little bit different. In the cloud, it's like a city, right? This beautiful city is a great representation of what we experience every day in the cloud. We were just talking about the information superhighway, right? It's literally that right there. There are hundreds of thousands of people crossing through these highways at all times at any given moment. And when you think about the city analogy, a city is like there are hundreds of thousands of people there at all times. If I'm thinking about New York, closest city to me, there are millions of people, right? When you have millions of people crammed into one place, you're going to have crime, you're going to have inefficiencies. These things will happen, but it becomes less so about how do I prevent every single thing from happening, and it becomes more about how do I actually identify and react and assume that things are going to happen in particular areas. I know that this area is a hotspot, so I need to protect that. Maybe I have police patrolling that area 24/7, right? You obviously don't have an infinite number of police, right? So you can't have cops patrolling every area of the city. It's similar in the cloud, right? In the cloud, we lean more on our monitoring tools, on our security platforms to identify risks, hopefully before they happen, identify possible risks, and give us notifications on things that might be insecure or might leave a little more to be desired for your security posture, right? And what does that look like in the shared responsibility model? Well, strictly infrastructure as a service. AWS is responsible for, as I mentioned before, the hardware itself and the software, EC2, EBS, things like that. The customer is responsible for everything else: your applications, your users, your data stores, your networking connections, subnets, VPCs, ports that are open, any configurations around that. Customer is responsible for that. AWS has been making tremendous strides to take some of this responsibility away from the customers as well, as we're moving more towards modernized infrastructures like container services, right? Container services actually abstracts a little bit more away from you, right? Since containers are an abstraction layer, it's an extra virtualization layer on top of that virtual machine. You don't actually have to worry about the underlying operating system as much. Also, you don't need to worry about the networking. Identity and access management, you only are talking about whoever is permitted into that container itself, which is really who has access to the app, which really comes down to the customer data, that customer content up top, right? Or you could go all the way super bleeding edge technologies and talk about serverless, right? Serverless like Lambda, DynamoDB, everything is going to be accessed via an API endpoint, right? So if you're accessing via APIs, you're not actually logging into any of the servers. There is no host. So a lot of the traditional security that we're talking about with infrastructure as a service or on-prem, when we have agent-based threat detection and IDS and IPS, data loss prevention, these kinds of tools that are agents that get installed at your operating system, they don't really exist for these services because it's completely serverless. And all of the responsibility really moves over to: how am I protecting my data? How am I making sure that it's encrypted, private, people don't have access to it? And people don't have access to it. You want to make sure that whoever does have access to these APIs is authenticated, right? Moves over to a zero trust model rather than an infrastructure model. And next, we'll be talking about the security design principles as a whole, and Lindsay is going to kick it off. Over to you.
Cool. Thanks, Donovan. So in this section, what I'd really like to talk about is, let's break out what the security design principles are, that some of which Donovan just mentioned. A strong identity foundation, enable traceability, apply security at all levels, encrypt everywhere. Let's talk about those security design principles, those best practices, and actually apply them to AWS and what that actually looks like. So AWS obviously has services that fit into each of these slots. So I'm not going to read off an exhaustive list of AWS services to you. You know that there are lots of them and they apply to all these use cases. Let's see how they apply. So I implement a strong identity foundation. Really, the principles of this are principle of least privilege, right? Enforce separation of duties, centralized identity management, and aim to eliminate reliance on long-term static credentials. So those are the principles we're trying to tackle here. So what does that actually look like in AWS? Let's go through some do's and don'ts. The top don't use your AWS account root user access keys. We see this all the time when me and Donovan do well-architected reviews, where the person who set up that AWS account initially used their personal email address, which is another no-no, and then continue to use that root account to administer the environment. Why is this a no-no, right? because that root account has access to do everything. And the more you use or share those credentials, the bigger risk you have to your organization of somebody just accessing the environment and deleting your entire account, right? Or doing something nefarious with it. Do implement automatic key rotation, right? This is actually a checkbox in AWS worth your time doing. Do use MFA everywhere, another checkbox. If you go into AWS IAM and you configure MFA as required for every user, it's a checkbox. Obviously, there's some user training that needs to happen on the back end. Hopefully you have MFA enabled in other areas of your organization, but that's a best practice. Don't leave default password policies and rotation settings. So when you configure an IAM user, you're going to see that the default policy is that password, that access key and secret access key, they live forever. And that's what you don't want, right? You want either a 90 or 60 or 120-day password rotation policy. When we start talking about compliance, PCI DSS is normally the standard kind of password rotation policy that we always keep in our minds. You know, SOC 2 will be like rotate your password regularly, right? And figure out what regularly means to you. PCI is very prescriptive. So PCI will say, rotate your password every 90 days. And that's what we tend to do, right? Do keep people away from data. So we're going to get into this pretty deep when we talk about networking and what this actually means. How are you, but in terms of user permissions, how are you giving someone, an IAM user, only the policies that they need to get the job done and not other policies? So if somebody doesn't need to access RDS, don't give them access to RDS, or that's the relational database service, AWS's managed database service. So how do we keep developers away from production data is a key principle here that we're going to get into. Don't grant anyone access to services they don't need. I just kind of said this, but essentially what tends to happen, which I'm going to get into in a minute, is that people give a developer all the permissions they need to get something done, and then they forget that they gave that developer all those permissions and never go back to revoke those permissions, right? So sometimes it is necessary to give somebody more permissions than they need temporarily. How do we do that with temporary access credentials like STS? And giving or if we have to do it on the user principle, how do we revoke those credentials over time? And we're really keeping an eye on that. So here are some of the services that AWS uses to kind of enable this, right? IAM, right? We all know that one. If we have an AWS account, we've touched IAM. Single sign-on. This becomes really important when we start talking about multi-account architectures, which Donovan will get into. AWS organizations is another one we're going to talk about during this immersion day. It's basically, how do we manage policies and permissions and access for a multi-account structure? If we have multiple accounts, how are we accessing accounts from each other, right? So that's where AWS organizations becomes really important. So again, here's an anti-pattern, right? In the beginning, we started out with our developers had their own IAM group policy, our finance team had their own read-only access, and our DBAs had their own policy. But then what happens over time, and this is really common, we see it a lot, is eventually that development team, maybe there's these 4 imaginary members of that development team. Over time, those individual members each have completely different sets of permissions, which means that it's really hard to know who has access to do what, right? Because if we're doing it based on the user rather than the group, it gets much harder to access. I mean, much harder to assess, especially when you don't just have 4 developers. Let's say you guys work in an enterprise, you have 100 developers and they each have their different IAM credentials. Suddenly you're getting into a situation where you're not sure who has access to what, right? That's an classic anti-pattern. Another anti-pattern, account overcrowding, right? So here's an image that I'm not going to try to parse for you guys, but you can see what happened. Essentially, a company had a lot of different VPCs launched in their environment. Maybe in the beginning, those different VPCs made complete sense and who had access to them made complete sense. But what happened was, you've got random developer in the middle who joined the team, and maybe you gave them access to all the VPCs or maybe only some of them. You've got a privileged admin who has access to all the VPCs, and suddenly it gets very complicated to try to figure out who has access to what VPC. So what are the security boundaries? Who has access to what, right? That's this ambiguity and is a level of risk that is the most common level of risk we see with this issue. So here's why we start introducing a multi-account architecture. And that's what Donovan's going to talk about. We're going to break out, rather than having all the VPCs in a single account with sort of ambiguous security boundaries, how do we break out each business unit or even tier of your application, so dev, test, prod, whatever, into its own account, so that basically we're able to audit and lock down this user only needs access to this specific account, and granting them access to other accounts is harder. There's a harder boundary between these resources and better organization of how users are given access to resources. Okay, let's talk about enable traceability. What does this mean? Right? It's monitoring, it's alerting, it's knowing what changes are taking place in your environment. But it's not just a technical thing, right? We also need to have a process with humans or an automated process to respond to alerts. How are those alerts responded to? Is that process documented? Do you have a documented process per alert? Or does your team get so many alerts that there's no applying human intelligence to those alerts? It becomes really cumbersome, right? So that's the theme of this section. So what are some do's and don'ts? Do enable CloudWatch detailed monitoring with the unified CloudWatch agent. It is basically when you set up an AWS account, you get CloudWatch default monitoring, right? That gives you things like CPU utilization and disk IO and all those kind of things. What does the unified CloudWatch agent give you? It gives you more, obviously, host level metrics. You can get memory. It also integrates with a lot of other services like AWS Systems Manager, which is a service we're going to talk about later, that helps you with all sorts of things like patching, access, SSH without needing a Bastion host, that kind of thing. Do enable CloudTrail everywhere. I would say this is probably the first thing we ask when we start having a compliance conversation with a customer. Do you have CloudTrail enabled? So what is CloudTrail, right? For the people who are new to AWS, CloudTrail is essentially logging all the API calls you make on your environment. So anytime somebody makes a change in your environment, launches a resource, changes the configuration, it would get logged in CloudTrail, right? Now, the key question that we're going to get to is, what do you do with your CloudTrail logs? So you've enabled them, but they're just sitting there in an S3 bucket somewhere that nobody looks at, right? So what do we do in terms of responding to potentially threatening actions that users are taking? Is something we're really going to have to get into. Centralizing application level, infrastructure level, and third-party alarms. So this gets into just what I was talking about, right? We don't just want to have CloudTrail enabled and CloudWatch enabled over here. And oh, by the way, we also have New Relic enabled, but it's going to a different user. And also we have a SEM that's ingesting all these alerts, but the alarms from the SEM is only going to the security team, right? So we have all these different sources of alarms and metrics. How do we centralize these sources as much as possible so that we're making unified decisions about where these alarms go and who's getting notified, and we're able to automate those actions? So that's definitely a do. Don't just assume that alerts are configured properly. Again, this is kind of the first thing when we get into an environment. Somebody says to us, you know, I get alarms in my inbox or to my text or in Slack or something like that. I get the alarms, so I assume all the alarms are set up properly. But in many cases, those alarms are just the default alarms, and you're not actually getting notified of the things that really matter in your account. So don't assume that things are set up properly. Really spend time going through what alarms you want to receive. Do have a process for each type of alert or activity. I already mentioned this, but this is not just about a technology, it's about having an incident response team, right? And do set up AWS config with managed rules. So I'm going to go into this in some depth in the compliance section, What this essentially means is AWS config is an additional cost, right? But you turn it on, but then what are you going to do with the alerts that come out of that? So AWS config will tell you things like, if this configuration changed on a resource, it was in compliance with this managed rule or out of compliance with this managed rule. So for instance, is MFA enabled everywhere is a classic AWS config managed rule. If somebody sets up a user and MFA is not enabled, AWS config would alert you to that, right? And then you have to decide, what are you going to do? Is that a human responding to that issue? Is that an automation response, et cetera, et cetera. So these are some of the tools, again, that I just mentioned that help with tracing and help with enabling traceability, as I said. CloudWatch, Config, CloudTrail, we just talked about these. Guard Duty is an intrusion detection tool, but it's a network intrusion detection tool. It's not a host-based intrusion detection tool, which we're going to get into what's required for compliance and what isn't. Here's the patterns and anti-patterns. So classic anti-pattern is all my alerts go to a Slack channel, and if we see something, we do something, right? What's the problem with this? The problem is, what if you don't see something? What if something happens at 2 a.m.? You know, you're expecting your developers to take action on something where the process isn't documented, they may go on vacation, et cetera, et cetera. So great that we've funneled all alarms into Slack, but how do we take that next step in maturity and make sure that somebody's responding to them, and that it's not just only if somebody happens to see something and has time to see it? Another classic anti-pattern. So reliance on customer feedback. So many times a client will not know that their application is down or their infrastructure is down or they're having some kind of performance degradation issue until customer service tells them about it, right? And obviously we can all see why that might be an issue. We'd like to detect issues before they reach our customers rather than after. Centralized monitoring. This is one of the patterns I just mentioned, the desired patterns, which is a centralized alerting engine. So whether alert is coming from your antivirus, which I represented by Trend Micro, but could be whatever it is for you guys, or Threat Stack, which is an IDS IPS, a host-based IDS IPS, or Datadog, or New Relic, or CloudWatch, or CloudTrail. How do we get all those alerts into a centralized alerting engine so that we can perform some kind of automation and intelligence on them? At Logicworks, we do this very simply with an in-house tool we built with Lambda functions. So it is completely possible for you guys to both obviously leverage the tool Logicworks uses or build it yourself. Question I get a lot, and I just inserted it here, is, can we bring our own security tools to AWS? So all the things I just mentioned, you know, Inspector and Guard Duty and all those kinds of things. What about our own security tools? What if we use F5 or we use Sophos or something like that? And the answer is yes, maybe, right? The answer is, if your tool scales up and down economically, great. But some tools were just not built for the cloud. So F5 is a classic example of something that tends to be pretty expensive in the cloud. Why? Because it has traditional ways of charging you for it. And it's not really used to ephemeral instances spinning up and down, right? So when you're doing your security tool evaluation, remember, is this security, are we bringing this to AWS just because it's convenient to us? We have some kind of contractual obligation with that third-party security tool? Or can we investigate some cloud native security tools, or at least third-party tools that have really spent a lot of time operating in the cloud so that we can have a more cloud native approach? So the short answer is yes, it's possible for you to bring mostly your on-prem security tools into AWS, but the question is, do you want to, right? Okay, apply security at all layers. Classic anti-pattern, everything in a public subnet. So for those of you who are very mature in your security framework, you may be shocked that I have this as an anti-pattern, as something that people actually do, but it happens, let me tell you, frequently. So what happens is, you know, Maybe they made a migration to AWS. There was some account chaos over the years. And what happened was all their resources, because their developers launched them, maybe one-off over time, all those resources, because the developers wanted to access them easily, they wanted to SSH into a public IP address, they put everything in a public subnet. Now, this is obviously an anti-pattern. What we want is for the only thing to be in a public subnet should be your load balancer and potentially like a bastion host, right? Everything else should be in private subnets with no internet connectivity, except out through a NAT gateway or something like that to the internet to pull down packages. So here are some of the security tools we're going to talk about in this section, right? The web application firewall, that's a layer 7 firewall that would sit in front of your resources, kind of that you'd attach to an application load balancer or a CloudFront, anything that's sitting in front of your application. AWS Network Firewall is a relatively new service that AWS launched that we're actually at Logicworks currently investigating for egress filtering. We'll see how that goes. Perimeter NACLs and security groups. So this is the bread and butter of firewalls in AWS, right? Really, security group rules are where security lives and dies in AWS. We're talking about that. And also AWS S3 bucket policies. So as Donovan mentioned, right, who has access to your data at rest? Is it encrypted? Can the internet reach it? All those sorts of questions are something that you control with AWS S3 bucket policies. So as I kind of just went into, this is another way of seeing the same information that I just conveyed, but I think it's helpful for some people to see it in a different way. The best practice is to have CloudFront, right? If you have web-facing application, right, a web application, you'd want CloudFront, which is AWS's CDN with WAF. WAF is actually like a feature that you can add to CloudFront easily. And then the only thing in the public subnet, again, is this application load balancer. And then your application is sitting in a private subnet with NAT access right out to the internet. But your database is sitting in a private subnet with no internet access, right? Because so only your instances perhaps are the things that are allowed to talk to Aurora, or potentially even this Lambda function allowed to talk to Aurora. That's just a different way of showing you the same thing. Okay, final section, protecting data at rest and in transit. So here are some of the tools you can use to protect data at rest and in transit. Macie, which is an S3 machine learning based tool that kind of scans your S3 account to detect PII, PHI, PCI. For those of you who have regulated data in your environments, Macie makes a ton of sense, and we'll get into that in a little bit. Key management service, right? The thing that hosts your keys and rotates them automatically. So previously, you had to have an on-prem key store, a cloud, an HSM or some kind. Now Key Management Store does all this work for you, especially if you're using AWS managed services. It's literally a checkbox in some of these managed services that gets stored in KMS, and then you go into KMS, you set up a key rotation policy, which is literally a checkbox in the console. It makes it so easy for you, easier than it really has ever been. So let's talk about, let's look at what I just said, which is essentially here on the left is RDS. This is your RDS console. And as you can see here, enable encryption is a yes or no field. And then you choose the master key from KMS you want to encrypt the database with. And on the right-hand side, this is creating an EBS volume, so an elastic block store volume, a volume that you'd attach to an instance or something like that. Again, encrypt this volume is a checkbox here, and you choose your master key. So I talked about S3 problems. We're going to keep returning to this again and again. Why? Because S3 data leaks are the most common kind of hack in AWS that exists, right? I'm sure you guys have heard of them. Some major companies have lost millions and millions of dollars because they accidentally put, a customer database or something unencrypted in S3. Maybe they even put it in a private bucket, but they didn't realize that that individual object had public access settings. And here's why this is so complicated, because AWS has multiple levels of security in S3. And that's actually not that user intuitive, I think. Sorry, AWS, if you're on the call. So how do you prevent this? A couple of things. Check S3 policies. If you have Trusted Advisor, if you have business support from AWS, you have Trusted Advisor. Look at Trusted Advisor and see what has public access from S3, right? Store S3 data encrypted. You can either encrypt existing objects with something called S3 encryption, nice name. I have a blog post that I wrote on that I can send to you guys if you're interested. Or obviously, if from the previous screen, if you encrypted your RDS database or you encrypted an EBS volume and you take a snapshot of that encrypted volume, it's already automatically encrypted when it's stored in S3. So you've got a leg up there. Turn off public access on buckets wherever possible, right? And enable Amazon Macie, a feature I just described, which is that machine learning based tool that scans your public buckets for PII, PCI, and PHI. Logicworks has actually built a tool based on Amazon Macie called Logicworks Data Loss Prevention, which does all of these things that I've just listed kind of in one tool. So if you enable that Logicworks tool that's available to our managed services customers, it checks all of these boxes for you and does that proactive monitoring. If you guys are going to do it yourself, it's a lot of work to kind of detect what policies you actually have and lock those down, but it's critical. And finally, setting up config alerts if somebody creates a publicly accessible bucket. Again, we come back to AWS config. You can get an alarm if somebody sets up a publicly accessible bucket or uploads an unencrypted object to a publicly accessible bucket, right? So cool, that's the end of the security foundations deck. I'm gonna stop there and see if I have any questions in the Q&A portion, or feel free, I've kind of allowed, I think one more person joined, I just allowed you to talk. Anybody can unmute yourselves and ask a question about the segment I just went through.
I think we do have one question, but also we have another unrelated question from Bhushan, which is, could the webinar video be made available to everybody?
Absolutely. So I will, I'm recording this session. I'll send it to everyone after the meeting. If you signed up with whatever email address you signed up with.
Okay, this question that we have here is, we actually have two. So one is, you mentioned centralized egress. I know that PCI has a requirement, and in many cases, high trust. How do you maintain centralized egress in AWS?
Yeah, so really there are a couple of principles we follow. The first is we like to think about central egress controls in a separate VPC. So if we have a multi-VPC structure, whatever resources are trying to reach the internet, we want them to go through the same point. Why? Because we want all traffic to be funneled through one point so that we can audit it properly. So what are actually the appliances that we're putting in this egress VPC, as we like to call it? There are kind of a couple of options. The first, and the option that we like to do, is Palo Alto. So Palo Alto, obviously you guys have all heard of the company, it's a firewall. We install it as a virtual appliance, like sitting on an EC2 instance in the egress VPC, and all traffic flows through that. We deploy it in multiple availability zones so that it's highly available. We are, as I mentioned in this talk, looking into AWS Network Firewall, which is a relatively new service that AWS launched to kind of fill that gap in their product suite so that we could use a cloud native services rather than a third-party service. That investigation is kind of ongoing. We've had a lot of discussions about what features are in Network Firewall that aren't in a Palo Alto that we could maybe use. But that certainly checks the box for egress filtering for PCI and some other frameworks. Donovan, I don't know if you have anything to add there.
Yeah, I'll add a couple things. So one is Transit Gateway. So our VP of Professional Services always asks in his interview questions, what is your favorite AWS service? And If you ask him, it's Transit Gateway because it gives you so many capabilities, and it makes everything simpler. But Transit Gateway gives you many capabilities with just this idea of centralized egress, right? So whether you're using a Palo Alto or not, just the fact of using Transit Gateway to centralize all of your egress gives you not only that benefit and the URL monitoring and whatever is going to be associated with that, but also you can minimize your NATs, right? You can centralize your NATing so you don't have a NAT gateway in every single availability zone in every single VPC, so for many of our customers that are multi-customer, single tenant SaaS customers, and they have 100 accounts with 3 VPCs each, it's like thousands of dollars on NAT gateway costs, right? And if you centralize that to a single NAT gateway, you're kind of killing 2 birds with 1 stone with that centralized egress, right? So I would add that. We have a couple questions. Oh, would we get a video recording of this one? Yes, we are recording this and it will be shared.
Yep. Cool.
All right. Oh, and it will be posted on YouTube, I am informed.
Oh, there you go.
Okay. All right. So I think we are good to keep going then, if there are no other questions. So I am next up. Let me share my screen. I think we're pretty much on time.
Yeah, we're perfectly on time. It's a miracle.
Yeah, that never happens. Okay, share screen, share PowerPoint. All right, Lindsay, can you give me a quick thumbs up if you can see my screen? All right, boom.
Looks great.
So, best practices in AWS, right? How do we actually determine what best practices are? And that's a great question because it's this buzzword that's used. It's an omnipresent word. Everybody's like, oh, I want to follow best practices, but what are best practices, right? Well, we actually have a few. The Cloud Adoption Framework, which is AWS's basically 6 pillars of not excellence, but just frameworks that you need to follow when you're thinking about, business perspective, platform perspective, people perspective, operations, security, and governance, right? Then there's the well-architected framework, which is 5 pillars, as we talked about before. There's security, operations, reliability, cost optimization, and I don't know what one I didn't say, but
operational excellence. Did you say operational excellence?
I think so.
Reliability, performance, operational excellence, security, and cost. Okay, yeah.
And then there's the AWS Architecture Center, right? Which you can find online. It has all of the white papers that AWS has. It includes the CAF, the well-architected framework, with all of the lenses, right? There's a serverless lens, there's security lens, right? They also have quick starts, trainings, technical guides, all focused on security that you can go to that actually denote what AWS says is a best practice. Beyond that, if we're moving away from the AWS realm, CIS, right? The Center for Security, for Internet Security. I'm sure you all are familiar with CIS hardened instances, right? We actually go through a lot of work at Logicworks to CIS harden. We actually just created a whole image pipeline for continually CIS hardened patched images, right? You can get CIS hardened images in the marketplace, but anyway, CIS is a standard framework that has a number of guidelines that you should follow in order to maintain what they determine as best practice infrastructure, right? Now, there are some things that with all of these can be ignored, right? Sometimes if you have a specific requirement for your application, maybe that guideline doesn't have to be followed, but you have to have a really good reason for it, right? For example, Docker, CIS hardened instances, one of the guidelines says that you need to have IPv4 port forwarding disabled, right? But Docker actually requires it to be enabled. So they're kind of at odds, but if you're running Docker and you need to have Docker for your application, I'm not going to say, well, I'm not going to run Docker anymore because sys says I shouldn't, So those things you can omit, but for the most part, 98% of them should be followed. Just a bit more about sys benchmarks, right? We want to identify the what, the why, check to make sure that these are actually enabled, and if they're not, we want to fix it, right? For example, Lindsay mentioned before, CloudTrail being enabled in all regions is actually a scored metric as according to the Center for Internet Security, right? AWS makes this pretty easy. You can actually have a centralized CloudTrail log that monitors all regions and sends it to a single recorder in a single centralized S3 bucket, right? But once you actually look at these, you need to remediate it if you're not actually deployed. And then the ways to remediate that, pretty simple. You can go through the management console, you can do it via CLI, or you can create some automation tools. That's what I was talking about earlier with Logicworks. We have some proprietary automation that's continually monitoring our customer environments to make sure that these are turned on, enabled, and centrally recording in all environments. So let's talk about a couple scenarios here, right? I really like this analogy, this whatever use case. I don't know. We're going to follow Alice and Bill. Alice follows best practices because she's Alice and she's awesome. Bill does not follow best practices because, sorry, Bill.
He's got a weird hair flick. That must be why.
Exactly.
Yeah.
Exactly. He's got the weird hair flick and the little indentation in the middle. It's like, come on, dude, one or the other. So Bill's environment. Well, Bill has an AWS environment in a single account, a single VPC with some S3 buckets, right? Let's say that there's an intruder that comes to attack his environment. How well is he posed? Poised? Well, I'm going to move my videos over here so that I can see. The intruder has direct access to the vulnerable web application, right? Because it's just straight from the internet to the internet gateway right into the web server, right? They then have access to the data service, probably because they're in the same VPC, same security group, same policies. You could just jump from one to the other, right? And then that intruder actually goes and deletes website image files, right? What is he actually doing here? We've all seen this before, typical ransomware attack. You're going to take the stuff and be like, no, you guys can't have it. We're going to change permissions to the backup and then say, give me all your money, right? Download the data, and then you don't have access to your own stuff. Why is this a problem? Well, there's no web application protection at the internet layer. There's no segmentation between the web server and the internal data service, right? As I mentioned, they're probably in the same security group, and they're clearly in the same VPC, probably in the same subnets. No segmentation there. It's a single account. So if the intruder rather got into that account, if it was a dev account, they wouldn't be able to get to production data, right? Because they're separate accounts. But since dev and prod are in the same account here, they have access to everything. No blast radius protection. All permissions are granted from that web server to the S3. They're probably pulling down data from the S3 into their application. So they have that open, probably not using a nice tool like AWS Private Link to make that a secure connection. And then that backup data isn't encrypted. So the intruder could just pull it down, have access to it, change permissions, and then boom, you're out of it. Finally, there's no logging, monitoring, or alerting. So Bill had absolutely no idea that this happened, which is terrible. He found out months later, and he was like, guys, what happened to all our data? And they're like, I don't know, let's check the logs. There are no logs. You can't check the logs if there are no logs. So not a great time. Alice saw Bill, and she was like, I don't want that weird hair flick. I don't want his problems. I'm going to be nice and neat and proper, and I'm going to do mine right. So she's asking us for help. What can we do to help her? Well, first and foremost, as I'll get into a little later, we want to make sure that we have a secure foundation, right? That foundation is going to be at the simplest level, your account structure and your access structure, right? How do we actually make sure that we have a multi-account structure with the proper roles, access parameters, users, so that we can stop this from happening in the future? As I mentioned before, the blast radius is going to be a much smaller cone if they only have access to your dev or staging environment and they don't have access to prod, right? So first, let's set up a multi-account structure. Then let's have limited roles and grant temporary security credentials. Again, AWS makes this pretty easy because we can use things like STS, the simple token service, to create just-in-time access to your users, right? We can then associate those roles with those STS tokens and say, okay, I'm not actually going to have any users. You know, Bill and Alice, they're not going to be users. They're not going to have IAM profiles. I'm just going to have roles, and I'm going to attach them to specific resources in the AWS environment, but they're going to expire after 60 minutes. So if somebody had access to it, maybe you got the expired tokens. You got my expired access keys at 61 minutes. They're not going to do anything. You just have a weird string of the weirdest, most awkward letters ever in the world. Seriously, these tokens are like 400 characters long. It's crazy. And then finally, federate to an existing identity service. There are a ton of services out there. You know, most people are using Active Directory, but anything that has like a SAML connection, you'd want to use. And as Okta has become a more prevalent tool in the community and the market, they are getting more and more tooling to support this, right? So Okta, you can use it as your identity provider. You can also use it as your MFA. You can use it as, they have a tool called ASA, which is the advanced server access. So you can just log in directly to your instances, having a zero trust model, fully logged, right? You want to make sure that you're federating to one of these services with multi-factor authentication so that you actually have that authorization, right? You don't want somebody to just log in, as I mentioned before, with the IAM users. It's just not a great practice. So what does Alice's environment look like? Well, we've still got that AWS cloud. There was that single account that Bill had. Let's make it actually 2 accounts. So now we've got our dev environment and our prod environment. Let's create some IAM roles. That's those hard hats you see there. They're going to have a role, maybe with those simple token service temporary access credentials so that you only have just-in-time access. When a user actually tries to log in, they have multi-factor authentication. You can only be authorized with that secondary level of access. And then we store our credentials in AWS SSM Secrets Manager, right? Which is again locked down. If everything is done via MFA, you don't have to worry about other people having access to it. It's a very secure parameter store. And that's that for that. Logging and monitoring. Remember, Bill didn't have any of his logging turned on? Well, bad Bill. Let's turn on all logging for all accounts, for all services in all regions. I love the word all. My friends get mad at me because they're like, you can't generalize. I always talk about every and most and whatever. I generalize most things. It's not great in a lot of cases, but in AWS, it's a great practice. You know, as Lindsay said before, encrypt everything, monitor everything, log everything. Otherwise, you're not going to be set up for success, right? But if you're set up for success with your logging, even if you're not paying attention, you could just look back and be like, oh man, somebody logged in and changed this thing. I can see that in my CloudTrail, right? Amazon Guard Duty is a threat detection tool. It'll alert you. It'll prevent some weird malicious attacks into your environment. It'll actually create a whole network of do not attempt lists, right? You can actually block with guard duty, right? We want to monitor an alert and it'll tell you, hey, some weird stuff is going on. You want to turn these things on. And it's actually pretty straightforward to just turn it on. To configure it takes a little bit more work, but to just turn it on with the basic rule sets, a few clicks of a button. Then, as I mentioned, monitoring and alerting, we want to make sure that we're actually getting those alerts. As Lindsay said, just having some alerts sent to your Slack channel isn't really sufficient, but we want to have maybe a centralized dashboard, right? I wish I had a centralized dashboard in AWS. Oh, wait, there's this thing called the Security Hub that is a centralized dashboard that can take in your config rules, your config alerts, your CloudTrail, and then any monitoring from other tools like GuardDuty, third-party tools that you might be leveraging. And then it can send those alarms to you via email, via Slack, via SMS. Really, anything that can connect to an SNS topic can be notified, right? And then finally, you're going to have a separate AWS account to fetch and store copies of your logs. So what does this one look like? Well, let's add all these monitoring tools in there. So now we've got, the first step is we've got our access to the environment lockdown. We've got our IAM with the MFA. Now we're monitoring everybody's access. But how do we keep the infrastructure safe? Well, we want to create a threat prevention layer using AWS Edge services. So I mentioned before, we have AWS Shield, which is enabled for all customers by default for a select few services, right? Route 53, CloudFront, these very, very edge services are secured with AWS Shield by default because it's basically the perimeter of all of AWS. If you wanted to get additional support from Shield, you actually get a whole SOC. It's about $3,000 a month, but it gives you a lot more granular permissions into how you actually secure against DDoS attacks and have that threat detection layer, threat prevention layer. You can say this specific EC2 instance, this specific ELB within my environment, I want to have X, Y, and Z permissions, right? AWS WAF, the well-architected framework, the web application firewall can be put in front of CloudFront, right, to make sure that any access that gets into your environment is actually going through that firewall. And then CloudFront is the content delivery network that makes it really easy for you guys to share. And along with these two tools, you can make sure that anybody who's accessing it is the right people to be accessing it. We want to create network zones with your VPCs and your security groups. Bill didn't have any security groups, but within this VPC, we want to make sure that we have isolated security groups for our databases, for our web apps, for our application servers, for utility servers, anything that basically has a different set of permissions or a different use case within your application, I think should get a security group. And then finally, we want to make sure that things are patched and scanned for vulnerabilities. Use Amazon Inspector. You can use third-party tools if you'd like. There are a ton of free ones out there, you know, Tenable, Nessus, whatever. But you just want to make sure that you are identifying the vulnerabilities in the environment and then patching them. So what does this one look like? Well, now instead of one giant VPC with no security groups, we have two VPCs in each account with the security groups at each instance, right? So now if an intruder tries to come in, they have nowhere to go here. CloudFront is right by that internet. After CloudFront, goes through the web application firewall, and AWS Shield is automatically deployed in the backend. So you don't have to worry about those DDoS attacks that we were talking about. Finally, we're going to use Amazon Inspector to make sure that the instances that you guys have deployed are safe and patched and you don't have any vulnerabilities. Finally, how do we protect the data itself? It's easy as 1, 2, 3, or 10, 11, and 12, as the slide would say. Well, we want to encrypt data at rest everywhere. We want to encrypt data in transit everywhere, right? Here it says with occasional exceptions. I kind of disagree with that. I think it should be everywhere because then, like I said before, you don't have to think about it. It's just like everything is encrypted. Chances of you needing to access something that's not encrypted, slim, right? So let's just encrypt everything and make sure that it's secure. Also, we'll have server-side encryption provided with managed keys, as Lindsay was talking about before. KMS managed keys actually rotate for you, right? So you don't have to worry about, oh, well, I'm going to have to manage my HSM, and then I'm going to have to patch my HSM, and then I'm going to have to worry about rotating, keeping these policies. It handles a lot of that for you, especially if you're using managed services like AWS RDS, right? It handles all of the encryption and the management and rotation. So we have the ACM, which is the certificate manager. We have certs on all of our load balancers, terminating all the way at the instance. We have AWS KMS that is encrypting, managing your keys, and then rotating whenever necessary. And now we've got a pretty good security posture, right? I don't really see how ooh, I did not mean to do that. I don't really see how an intruder can come in. Let me, am I still sharing my screen?
No.
Okay. Am I now?
There you go. Yes, we're
Okay.
back.
I'm going to go all the way back to this picture here with the intruder going through every one of these. And what's the first thing that he gets to? The internet gateway, and then the instance, right? Now, all the way at the end, let's see how he can do that. Well, he can't. If an intruder tried to come, internet to CloudFront to the WAF is going to be like, no, sir. No, sirree, Bob, you can't get in here. So that just the rest of the image just doesn't even matter at that point. But let's say that they tried to get somewhere else. Let's say they are super duper hackers, and they somehow are able to get past the WAF and the shield, and they got into the instance. Well, the security group at that instance says, nope, we're actually default denying anything that's not explicitly allowed, right? I'm only going to allow 172.15.62.5, right? Well, if I'm not 172 dot whatever I just said, then I'm not going to get in there, right? So then let's try to get into these S3 buckets. Well, can't get into the S3 buckets either because they're encrypted, they're private. I can't even see the contents. I can't even see the URL. It's completely private, right? So with this security posture, Alice is fully set up for success. She doesn't have to worry about her intruders, and she doesn't have to worry about her weird cowlick either. So,
Awesome.
all right.
Cool. Well, we have some questions actually from your session. And for those of you who don't know, questions are anonymous. So you submit them to us, we'll read them out, but we won't announce your name to the group unless you want us to. But we have some anonymously submitted questions. So Donovan, I'm gonna just go into it. You actually just mentioned terminating SSL. So we have a question about where should I terminate SSL? What's the best practice?
Yeah, good question. It has gone all over the place for the last few years, right? Well, should it be at the load balancer? Should it be at the instance? I think best practice is that it should be terminated all the way. Well, you should be encrypted in transit all the way to the instance. I'll say it that way, right?
Okay.
And the way that you do that is you have your certs that are terminating at the load balancer itself, but then you're going to have self-signed certs that go all the way to the instance, right? So you can't actually terminate the certificate itself at the instance when you have a load balancer in front of it, but then you need to have those self-signed certs so that whenever customers are actually accessing your site, they are still going to have the encryption in transit. So at the instance, all the way, you want to make sure everything is encrypted throughout the entire process of the access.
And just a follow-up question that I'll add. What do you use to encrypt to do self-signed certs?
Yeah, so you can use the AWS certificate manager, and you can also bring your own certs if you wanted to. But really, it's up to you and your preference. If you did ACM, then there is a little bit of a process there, but yeah, either one.
Okay, cool. Okay, then we have, I'll abbreviate this question that the person asked, but do I really need a multi-account structure to be secure? What if I've already got, I assume they're asking, what if I've already got, a single account with multiple VPCs? Is it impossible to be secure with that kind of environment?
Yeah, great question. It is not impossible. AWS has been around for 14 years now, right? You can imagine there are many customers who have a single account structure that are just as secure as somebody in a multi-account structure, right? The multi-account structure is less so about the actual security itself and more so about the ease of management when talking about security, right? When we're using a multi-account strategy, it's much easier to leverage service control policies that are overarching, that can go to specific organizational units or specific accounts, right? And as I mentioned before, the blast radius, there are some benefits that you get with a multi-account structure, just plain and simple with security. But if you do have a single account, it's not impossible. There are ways around it. It just becomes a little harder. That's all.
Got it. Cool. So I have a couple more, but before I get to them, I'll just open it up. Anybody who wants to unmute themselves to ask a question, feel free to do so. I'll give you a few seconds now before I jump into the rest of the questions that were submitted by message.
There are also a few people here that joined again.
Oh, allow them to talk. Great.
Yep, please. Thanks.
I'll do that. Great. Anybody have any questions? Okay, cool. I'm going to go back to my text-based submissions. If anybody wants to interrupt, feel free. Okay, so do I need a WAF, or is a security group enough? I assume a security group on an application load balancer is the question. Like, so do I actually need a WAF seems to be the question, either for compliance reasons or security reasons.
Yeah, good question. Do you need a WAF? Well, depending on what compliance requirement you have and depending on your app, there are some things that you can say maybe 80% of technologies are best practice recommended and probably required in order to maintain a proper security posture. But there are some things that vary based on your application, right? The web application firewall is specifically at the layer 7, right? It's at that app layer. Not everybody needs to secure that, right? If you have internal processes, you don't really have any front end customer facing applications. It's all private. No, you don't really need a WAF. It's still good to have, because in worst case scenario, super duper hack bro, hacksaw might be able to get in there. But you don't need it. Again, these are all best practices that are recommended, but there are some certain cases that you don't need to necessarily follow. And then in terms of compliance, compliance is really just, I don't know that any compliance requirement requires a WAF itself. The controls are more nebulous. It's like, oh, we want to make sure that you have protection at the application and data layer, right? And that can be encryption at your database. It can be permissions. It can be threat detection at the host. It doesn't have to be a WAF.
Got it. So like for I think it's 8 of you, for those of you here in the beginning, answered that you need SOC 2 compliance. That's a risk, as I'll get into, that's a risk-based assessment, where the conversation that Donovan just had, where he's like, do you need it or do you not, is part of the risk-based assessment that you and your assessor kind of go through to determine, okay, maybe you only actually need a layer 4 firewall here, which would be a security group, right? On your application load balancer, or maybe the risk is high enough that a WAF makes sense. I think a WAF the cost factor is like, we often see it's costing about $300 to $400 a month. Just so you guys have like a rough estimate, because I know the costing in AWS is based on basically the number of managed rules you have. So it can be kind of hard to know, what is that thing going to cost me? But basically that's what it costs in AWS. Okay, cool. We have a question here. Can you share any good practices on cross-account or cross-corporate account access? For example, access for S3.
Yes.
Sliding right into your control tower presentation,
Perfect.
Donovan.
Yeah.
Yeah.
This is a great, did she pay you to ask that?
I think not.
So yes, I'll touch on that a little bit more in the next presentation, but talking specifically about that right now, yes, there are some great best practices for cross-account access, for cross-account roles, right? The organization concept, AWS organizations, allows you to create these service control policies, and config roles, config rules, and detective and preventative guardrails, right? You can configure all of these. And within those, I think that's the first building block into the security for tools like S3 or EC2. You know, you can say that I want X, Y, and Z accounts to have access to A, B, and C accounts. And then I want all of the accounts between C and X to not have access to each other, right? You can actually define that with your service control policies, right? Then beyond the service control policies, it comes back to that IAM, right? We want to make sure that there's an IAM role specifically designed for what accounts have what access. This is something that Logicworks runs into every other day, because we have hundreds of customers that are managed services customers, and we're building them in a customer-owned environment, right? It's a customer-owned account, but it's managed via Logicworks management account, right? So in order for us to actually have access to our customer environments, we need to have strict access cross-account roles to access those environments, right? The overall best practice is the principle of least privilege, right? When you say access for S3, do they need read-only access? Who needs write access? Who needs to see different versions, right?
You can also lock
That,
down per bucket. You know, you could
yeah,
give a role that just has access to a specific bucket or even a specific object.
exactly. So overarching, you want to make sure that you have the principle of least privilege wherever that access is required for each one of these cross-account roles. But it's done via SCPs, those service control policies, and identity and access management, the IAM roles.
Cool. Well, since we're on the topic, and it seems like I've run through the question, do you want to jump into control tower, option A, or do you want to take a little bit of a break and come back and go into control tower? Donovan, what's your preference?
I think we'll do control tower and then break.
Perfect. So
Yeah.
over to you.
Since we're on the topic.
I think we're on the topic. Let's just jump into it.
Yeah.
Great.
All right. Let me share my screen. Give me a quick thumbs up, Lindsay. All right. So can you guys share some best practices around multi-account structures? Well, yes, I can. How do we actually control a multi-account structure? Well, AWS was like, I've got just the thing for you. Control tower. Let's talk about why we would want to have a multi-account structure, and then we'll talk about what the framework looks like. Well, as we mentioned before, there are some reasons why you do want a multi-account structure that just by default give you a better posture for your security profile, right? First, I mentioned before that blast radius, right? You want to make sure that anything that's production, you have locked down to just production. Those service control policies that I was talking about before, you can create a service control policy that says all developers, anybody that's accessing the environment, can only access dev and staging resources, and no users actually can log into a production environment, right? That's going to stop you from intruders as well, because nobody can log into that account. right? So at the very, very top, that foundational environment, just the organization tells you that you're already off to a better start, right? Much harder to do in a single account structure. In a single account structure, you can still do that with VPCs and subnets, and you can lock down the VPCs with NACLs, the subnets with NACLs, and the security groups at the instance layer. But you can't really say, oh, this account versus that account with an SCP because you're in a single account, right? So what does this framework look like? Well, you can create these things called organizational units, right? And by default, out of the box with a tool like Control Tower or AWS Landing Zone, they create a core organizational unit, the foundational organizational unit, that's going to be your security, log, archive, your shared services, networking, any core service account that isn't really application, but everything sort of uses it. It creates those accounts by default in that organizational unit. You can have as many of these core accounts as necessary. By default, it creates, as I mentioned, security, log, and shared services. Logicworks always recommends having a network account in there as well, as we were just talking about that transit gateway, centralized egress, Palo Alto. When you have a virtual appliance like that, the best practice there is to have it all come through a centralized ingress point, and then we can branch out with that transit gateway, right? Rather than having individual VPN connections to and from every account, every on-premises data center, it's much easier to have a hub and spoke model where we centralize your access and then branch out from there, right? Then you can create additional OUs after that, right? You can have a sandbox OU, you can have your production workloads, you can have suspended stuff that's terminated environments, right? Well, I don't really have this. I'll move it over to that organizational unit, right? And the nice thing about this is you can move accounts throughout organizational units whenever necessary. And then those service control policies that I was talking about automatically are applied to the organizational unit. So if I say everything within suspended, uh, no access from users, there's no IAM roles, they don't have access to any EC2, abstract away all services. As soon as you move in a new account into that organizational unit, it automatically inherits those policies, right? So within each of these accounts, or within each of these organizational units, you have these accounts, right? As I mentioned, you can have your different SDLC tiers and then your prod account. You can have that for your security, for your infrastructure, for your workloads. And this is what the security workflow looks like, right? So the blue lines are the log flow. I removed the network path because I think it gets a little confusing, but really I'm just concerned about the log flow, right? Every single account that you're going to deploy in your multi-account framework is going to have connections back to that logging account. And with Control Tower, it does that by default, right? With this idea of an account factory that I'll get into in a little bit. Any new account that you have automatically has some prerequisites that are deployed, including setting up CloudTrail, setting up config, and making sure that these logs are centralized in that log archive account in a centralized S3 bucket. I've mentioned this idea of Control Tower a few times. What is it? Why are we talking about it? Why do we love it? Control Tower is the new best practice, the latest, I should say, best practice for designing and building, maintaining a multi-account environment in AWS. It's a self-service solution. It's pretty nifty, neat, and easily accessible within your console. The previous iteration of Control Tower was called the AWS Landing Zone, and you had to manage it yourself. You had a giant library of CloudFormation templates that you had to configure yourself, deploy yourself, manage your pipeline yourself, and if something broke, it was really hard to troubleshoot because you've got like hundreds of thousands of lines of CloudFormation code that you're going through, right? AWS has abstracted that now and does everything on the back end and just gives you access to the Control Tower, which is everything that you need. All those accounts, the networking necessary, the service catalogs, the account factory, as well as additional add-ons. Let's say, well, I know that Control Tower centralizes my logs for CloudTrail and config, but I also want to centralize application logging, right? That's obviously not going to be out of the box, but you can create an add-in that's applied to your Control Tower so that every new account can actually be automatically discovered with the centralized logging tool that you've built, right? So it really is easy for you to build additional automation. And that sentence up here says it all. It's the easiest self-service solution to automate the setup of your multi-account environments. Lindsay, your question before, is it required to maintain a multi-account structure for security? No, but it allows us to automate most things, which makes it a lot easier to manage. So what happens when we set up that AWS landing zone with this control tower? I mentioned before, we get these 3 core accounts under that organizational unit, right? That core OU. You get your log account, your audit account, and your provision accounts, right? That's your custom OU. Within the master account, Control Tower gets deployed, which actually leverages AWS organizations. You can use AWS single sign-on. So if you think back to Bill and Alice, the first point that you needed was a secure foundational account environment, as well as your IAM and multi-factor authentication, right? You need to federate to some identity source. So all of that's handled right here, right? We've got organizations with single sign-on that's federating to your identity source with multi-factor authentication, right? And then Control Tower is going to be deploying AWS stack sets, the CloudFormation stack sets, and Service Catalog to deploy new environments within this environment, right? The question that you guys posed in the chat, cross-account audit access via SSO and AWS IAM is all handled within the Control Tower itself and within those cross-account roles. Finally, the last thing that I think is worth mentioning is that you can have centralized monitoring and notifications with CloudWatch and SNS, right? Again, you don't have to worry about, oh, I'm managing each of these accounts individually. We can centralize all of our alerts from every account into a centralized dashboard with that security hub that we were talking about before, or even if you have your own. Logicworks, we've built our own since we have our own 24/7 NOC, right? But as long as the tool has a webhook or an API call that we can leverage, we can centralize all of our monitoring alerts and expose that to our NOC, right? All of that is based off of these softwares and tools by default, right? We use Amazon CloudWatch because it's so feature rich. It allows us to log things. It allows us to alert. Again, SNS allows us to send that via a Slack message, an email, a text, anything that connects to that SNS topic. So within this multi-account, let's break it down into these OUs, right? So the master account, as I mentioned, is going to have the control tower. It's going to be your master payer, so you don't have to worry about paying. I'm getting a bill for every one of my 400 accounts in AWS. You're going to get one bill for that overall organization master account. And then everything under that is going to be under your OUs. It centralizes your identity and access, as we mentioned with the SSO, multi-factor authentication, and IAM, right? We can pre-configure permission sets for each account. That's what's really nice about this, right? When you're creating an account, you can say, well, everything in this OU, I want to have only read-only access to everything else. Done. You don't have to worry about it again. Or you can say, you know, not even at the OU level, I just want this account to only have read-only access. Or I want this OU to have admin. That's that principle of least privilege that we were talking about. We can get really granular on what resources and just spread it out wide. When you're thinking about larger organizations that are trying to migrate, and you know, we've got maybe 3 data centers and we've got a few hundred VMs, this is really helpful, right? Even if you're a small environment, it's still really helpful because you, back to that blast radius, let's say you've got an application with 5 instances. Those 5 instances, you're still going to have a dev, and you're going to have a stage, and you're going to have a prod and QA and UAT, right? You want your dev to have read-only access in the cross-account roles. You don't want it to be writing to production, right? Maybe you don't want it to have access at all, right? But that's where you get with these granular permissions that you can't really get with those single account architectures. So I've talked about these guardrails a bunch. Why is Control Tower so nice? Because it allows us to create these detective and preventative guardrails at the account and overall organizational structure, right? They're expressed in plain English that says, make sure that there's an S3 bucket policy that says that this is private, right? It says that, right? And you can apply that to everything. And as soon as something is, well, I was going to say as soon as it's deployed, but as soon as you try to deploy, it says, you can't actually deploy that because I have a preventative guardrail that says you can't do that, right? So it's actually blocking malicious or unintended changes in the environment. Then there are detective guardrails that are more so on the reactive side that can look, oh, this thing is deployed already, or somebody's accessing something, notify, here's an alert, now we can go and change that. There are some really neat tools out there, AWS config conformance packs. I believe that there's a SOC 2 one, there's a HIPAA one, but you can actually create these conformance packs and just deploy them that are predetermined, prescribed lists of config rules that should be deployed in your environment. And Control Tower has a baseline, right? They have these detective and preventative guardrails that are conformance packs, but then you can go even beyond that with the rest. What are some examples of these guardrails? I just mentioned the S3 bucket policies, but all of these, right? Again, back to your question about what are some best practices about the cross account? Well, let's make sure that we disallow public read access to S3 buckets. Let's make sure that CloudTrail and config are enabled, right? We don't want to enable RDP internet connections. You can do that for anything that, let's say you have a completely Linux-based environment, you don't even need to have RDP, right? You have SSH. So you can just disallow that for the entire infrastructure, right? That's just a few. I mentioned this idea of the account factory before. The account factory allows you to actually create these by default as you deploy every new account. So when you set up that initial account factory template, you can say, well, I want these accounts to have this, these permissions, has these SCPs, it's going to go in that OU. And then when you actually create the account, it's going to have everything that we just talked about. You don't have to worry about enabling this for every single account. It's pretty much plug and play. The work gets moved from the ongoing and moved into the upfront, right? You're investing in your upfront time to deployment so that later on you have the benefits of a seamless managed environment. Then you can actually add the service catalog on top of that. Let's say you have an application that you want to deploy, you're signing on a new customer and you want to give them dev access to some test trial, right? You just spin up a new account and then you have a service catalog product that says, this is a whole templated design of my whole application with AMIs deployed, patched, the applications already deployed, operating systems configured, few buttons, 20 minutes later, you have a whole account with your whole application already deployed with these guardrails in place. So you can share that out. And again, with these cross-account roles, they can't actually access your production stuff unless you give them explicit access, right? So you don't have to worry about, oh, if I'm giving them access to my AWS environment, then they're going to have access to my production data. That'll only happen if you explicitly allow it. Oh, look at that. Next slide. I jumped the gun with my service catalog example. So just to reiterate, you can organize, entitle, and publish your account factory to the accounts, and then your developers can actually self-provision based on whatever templates you have in that service catalog. And then finally, putting it all together, we just are allowed to automate the governance at scale. As I mentioned, every single one of these accounts, every single application, whatever you're actually deploying is going to have these things deployed by default. So your security teams, your platform teams aren't going to have to worry about, oh, did I configure the right IAM user or the right IAM role, and did I give permissions to S3 because it's going to be deployed as soon as you deploy the environment. And that's pretty much it.
Awesome, Donovan. Thanks for that. We did get some questions related to Control Tower that I think we can answer now. And then after this, guys, just so you know, we're going to take a break until 1. So you guys have time to go grab something and walk around. But let's just answer a few Control Tower related questions. We have a question. Is VPC peering a safe option between accounts, or does it open up a security loophole?
Yeah, VPC peering is a safe option for the most part, right? I would say that VPC peering is a prerequisite for some services that make it a little bit more secure, right? Let's say I mentioned before private link, right? If you wanted to have private link access certain S3 buckets from an EC2 instance, you're going to have some peering between those endpoints, right? If you have 2 EC2 instances over here in a VPC and you have 2 EC2 instances over here, you need to peer them somehow. The recommendation, however, would not be VPC peering for anything that goes greater than 2 VPCs, right? If you have a more sprawling environment, we'd want to start looking at Transit Gateway, because Transit Gateway is a lot more robust. It's more highly available and creates that hub and spoke network model that we were talking about. And you still have the same functionality from private link and VPC endpoints and things like that. But you also have that additional layer of centralized egress, centralized ingress, and those access with the controlled permissions. So VPC peering is safe, but for anything that is larger than a few, we'd recommend Transit Gateway. Lindsay, you have anything to add to that?
Yeah, no, I think that's good. I think maybe we should just define what is a VPC endpoint for people who don't know.
Yeah, a VPC endpoint actually allows you to basically have access to a resource without peering the whole VPC, right? So you can say, I want to just access this EC2 instance. You can create a VPC endpoint for that EC2 instance rather than peering the whole VPC.
Yeah, and the other benefit is it's traveling within your network, right? So if you had, for example, a VPC at S3 endpoint from your environment to S3, rather than it traversing the internet to get to S3, it's going over AWS's own internal networks to get there. So that's another security benefit. Okay, so I have a question. This is really a sticky question, so I'm going to read it out for everybody. When Control Tower was released, if you had already set up Landing Zone, which was kind of the predecessor to Control Tower for everyone who doesn't know, for your AWS accounts, you could not migrate them to Control Tower. So has that changed, Donovan?
Yes, and it's a great question. And as Lindsay said, it's very apt. We're talking about that a lot right now. We're actually thinking about setting up a whole campaign to send out and be like, hey, we could do this for you guys. So you couldn't actually migrate before because Control Tower required a whole new organizational structure. You needed a whole new organization and a master pair and blah, blah, blah. So if I just finished building this whole new thing with Landing Zone that also required an organization, I need to tear the whole thing down and then redo it, right?
Pain in the butt.
Yeah, very much of a pain in the butt. Not anymore. Now, actually, we are able to inherit existing organizations into a Control Tower, right? You can inherit accounts into a Control Tower. You can inherit an existing organization into a Control Tower, or vice versa. You can deploy Control Tower into an existing environment, right? Into an existing account structure. There are some things that do break, because if you are using Landing Zone add-ins and things like that, you no longer have access to the pipeline. So if you've made custom changes, then you're probably going to have to make some of those custom changes again, maybe refactor that to be an add-on in the Control Tower. but that's what Logicworks is for. We can help you with that. So
Cool. Thanks, Donovan. Is Control Tower able to manage both standard and GovCloud accounts?
yeah, that is a good question. GovCloud is more so like a region, right? And so yes, but some of the tools are going to be limited, right? Um, the
Yeah.
GovCloud resources are sorry, go ahead, Lindsay.
Yeah, I was just going to say the GovCloud resources are limited. And I think actually Control Tower is only in US East, US East 2, US West, and Ireland currently. I don't
Yeah.
actually even think it's in GovCloud as far as I know. And so I
So
think the answer is no. But
yeah,
I'm gonna
it's
double
really
check.
weird. It's really weird because you can't actually deploy. There's a difference between deploying Control Tower and then managing accounts that have regions, right? You
Hmm,
can't deploy Control Tower into a GovCloud account, right? It's only in those 5 accounts or 5
right.
regions rather. However, you can have accounts within the Control Tower that have GovCloud resources, right? So
Got
it's like
it.
a weird uh it's a weird
Would they be visible in the
paradox.
Control Tower console?
Yes.
Okay.
Yes.
So you can really manage them. That's cool.
Yeah.
Hope that answers your question, the person who asked that. Feel free to ask a follow-up if we didn't answer it. The
Yeah.
last question is actually unrelated to Control Tower, but about sys frameworks. So what I'm going to do, the person who asked about the sys framework question, I'm going to answer your question in the compliance section of the talk so that we can keep this just on Control Tower. Anybody want to unmute themselves, ask a question about Control Tower before we go to break? Now's your chance, or put it in the Q&A. This is going to be our last real segment on Control Tower. So when I give you a chance to get all your Control Tower questions out, because Donovan is the real Control Tower expert. I mean, how many Control Tower projects do you think we've done, Donovan?
Oh, I don't know.
Dozens
Probably
at
a
this point.
hundred. Yeah, probably a hundred
Hundreds.
at this point.
Okay,
Yeah.
100 at this point. Yeah. So we've done a lot of them. Cool. So it looks like that's all the questions on Control Tower. So now we've reached the break. So we are going to give you, we're running just 5 minutes behind, which is fine. I'd say we give ourselves a 15 or 20-minute break. We're going to be back in this room at 1:05 or 1:10. So go ahead, grab some coffee, grab some lunch if you have time to do so. And we'll see you all back here at 1:10. Thanks all.
Thanks, guys.
Oh, and for those who know and are still here, who want to know, the second half of this will be basically an hour and a half, and I'll be talking about compliance and DevSecOps and compliance automation for if you weren't here for the intro. So see you guys soon. Hey guys, this is just a 2-minute warning. We're going to get started in 2 minutes again on this immersion day. See you then. Hey all, I hope you grabbed some lunch if you were in the Eastern time zone or had a good break. Just a 60-second warning, we're going to get started here and then we'll get into our presentation on compliance. So another 60 seconds and then I'll get started. Donovan, just confirming you're there. Cool. Excellent. Thanks, Donovan. He's there. I can't hear you, Donovan. I don't know if you're muted. We didn't have a classic you're muted thing before in the first part of this section. So I'm glad we got that in before the end of the immersion day. You know, it's really important to check that box.
That was actually the classic, my Bluetooth is not connected.
There you go.
Yeah, cool. But I am super repping Logicworks. I showed you guys the shirt before. Now I'm repping the mug, got my coffee. We are nice. Ready to go.
Excellent. Great. So it looks like we've got most of the people have hung on for the second part of the day. Thanks for hanging in there. Know this is a long session, just to kind of give you a sense of what's going to happen next, right? I'm going to go over the compliance deck as I discussed. It's going to take me about 40 minutes, about 40 minutes. And then we'll have some good time at the end, a solid 10 or 15 minutes for more Q&A. And this Q&A at the end of the session can be about anything that we talked about today, not just compliance, it could be about anything. So we'll have plenty of time for that. And again, if you'd like, after the session is complete, after the Q&A is complete, me and Donovan are going to be around. If you guys want to stick around and ask us some questions, we can do that one-off with you guys so that, you know, if you have a security question that we didn't answer, maybe it's kind of sensitive to ask in a public forum, we're of course happy to help answer that. If you want to schedule that, just put it in the chat to panelists and say, hey, I'd really like to chat with you guys after. We're totally happy to do that. And again, I know that there are a few people joined since I did that first introduction. So for those new people who have joined, if you want to ask a question, do so in the Q&A field. If you want to, and the questions are private, only me and Donovan see them. If you want to interrupt and ask us a question, either during while I'm talking or at the end of the Q&A session, feel free to do that. Because this was a limited invitation immersion day, so no worries about interrupting us and asking any questions, unlike a typical webinar. Great. So I'm going to share my screen and get started.
I'm also going to clarify, if you guys did want to have a breakout session, if you could just chat us right now, depending on how many people there are, I might
That's a
need to
good
bring in
point.
some additional resources. So I just want to make sure.
Yeah, we're all covered.
So yeah, just in the chat, just to the panelists, you want to have a breakout session, please. Thank you.
Thanks, Donovan. Cool. All right, let's get into it. So I know that compliance, is potentially not the most exciting topic that ever was, but we're going to try to make it exciting. It sounds like most of you already have, one second, I got to switch this. Come on. Okay, I'm going to stop sharing and do this. 1 second, give me a swap, minimize, reshare. Sounds like most of you guys already have a compliance framework that you're already meeting. So potentially some of this is going to be review for you guys. And then we'll get into the automation piece about how to make compliance easier, because who wants to do manual compliance? Nobody. Okay, foundations of compliance. So AWS makes it very clear to you guys, I think, that they themselves have to comply with all these frameworks and go through all these audits, right? So if you wanted to access their audit reports or learn more about how AWS themselves treat compliance, I highly recommend you check on AWS Compliance, which is like a microsite that they have, and also AWS Artifact. So years ago, if you wanted to get, for instance, Amazon's SOC 2 attestation of compliance, you needed to email them and get the report, right? Or sign it. I think you had to sign an NDA, right, Donovan? Now it's self-service. You go into AWS Artifact, you pull the report, bada bing, bada boom, you're done. So highly recommend you check that out. So we talked about this in the security section, Donovan did in that initial section, but a lot of customers come to us, they're like, maybe we understand the shared responsibility model as it comes to security or management or that kind of thing, but compliance, if AWS is compliant with PCI DSS, or AWS listed all of these services as HIPAA enabled, does that mean if I use that service, I'm automatically HIPAA compliant on my infrastructure? It's actually a tougher question sometimes than the security question, right? Or the responsibility question. So the answer is that AWS certifies their own physical resources, their own team, but you still have to get your own accreditation of compliance, your own certifications, and do your own external audits. Even when you work with a partner, a managed service partner like Logicworks, for instance, you still need to have your own audits, right? So somebody like Logicworks, so AWS is PCI certified, Logicworks is PCI certified, right? So what's your responsibility, even if you worked with us? You would actually also need to get PCI certified if you have PCI data, right? Because we might cover the infrastructure controls portion or patching and that kind of thing, but you still need the application control level, right? So that's what the shared responsibility model looks like in the compliance world. If you, for instance, use, like I said, those HIPAA enabled services, let's say if you're HIPAA, I think one or two of you, it doesn't automatically mean that you're HIPAA compliant. It means that you could architect those services to comply with HIPAA if you do it the right way, right? So still that line of demarcation between you and AWS is really on, AWS will provide the service to you, like IAM, for instance, which is HIPAA enabled, but you could create an IAM user that gives the world full access to your environment, right? And that's not AWS's problem. So that's the line of demarcation responsibility for compliance on AWS. So let's do a little bit of a poll. I'm going to launch really quick, just a knowledge check. So guys, look at your screens. You will see a pop-up on your screen. This is kind of a quiz, pop quiz what is AWS's responsibility and what is your responsibility for each of these things. So the first one is getting an attestation of compliance for your organization, right? We just talked about that. If you were listening, you'll know the answer. Hardening your OS to align with the compliance control. Encrypting your database. Generating policy documentation. And finally, maintaining a SOC 2 report for an AWS data center control implementation. See, the responses are coming in. I'll just give you a few minutes to digest and answer. Cool. Looks like we're just waiting for one of you to respond. Maybe you don't want to respond. So I'm just gonna, oh, there it is. You answered. Thank you. Okay, cool. So I'm gonna end polling and I'm just gonna share the results because they're anonymous. Let's talk through each of these. So getting an attestation of compliance for your organization in meeting your framework or regulation. Most of you are right. It's your responsibility. It is not AWS's responsibility. As I said, AWS can provide you their attestation of compliance, but not yours. Hardening your OS to align with the compliance control. You're right. Most of you guys, it's your responsibility. Anything on the operating system level is your responsibility, unless you're doing something like RDS, right? Which you don't have access to the operating system level, which is something we discussed in the previous session, right? Then it's AWS's responsibility. Encrypting your RDS database. I knew that this would be a tough one, so I'm glad I asked this. The answer is, it is your responsibility, but let's get into it. So AWS provides the functionality to encrypt your database. Like I said, it's a checkbox. It's an option, essentially. And then they integrate in the background with KMS to make it happen. But it is your responsibility to enable encryption in your RDS database. So whether or not RDS is encrypted is your responsibility. Although RDS will handle some of the back-end processes for making it seamless. So ask a question if that's not clear, but that's the line that AWS draws. Generating policy documentation for AWS security policies. Now I realized this question was deliberately vague. So I said AWS security policies. You're probably wondering, did I mean AWS's security policies or did I mean my security policies on AWS? So the reality is you are responsible for documenting all of your own security policies, and AWS is responsible for documenting their security policies, which they make available to you in AWS Artifact. But it is your responsibility and your auditor, when they're sitting down with you to go through your compliance audit, if you say, I'm running on AWS, your auditor will go, great. I work with hundreds of clients who are on AWS and I have their attestation of compliance right here. That checks X, Y, and Z boxes, but now let's go through your AWS security policies that your team runs. That is, 90% of the audit, right? Okay, and finally, maintain a SOC 2 report for AWS data center control implementations. So that is AWS's responsibility. AWS data centers, you do not need to audit them. In fact, AWS doesn't let you audit them. They don't let third parties into their data centers. That's why they provide you with those attestations of compliance. So again, if there are any confusions about these sets of questions, let me know. I'm glad we went through this kind of session to understand responsibility. I asked these questions. Hopefully that helps clarify what seems like a broad generalization into some specific instances. Cool. Oh, I didn't realize there was all this. I forgot I put animation over all these. Okay, now we're here. The path to compliance maturity. So the first step to compliance maturity is, what should we be doing? That's often when we get on a call with a customer who, let's say they're a SaaS company, right? They just got a request from an end customer of theirs that's a healthcare company. And that healthcare company said, we need you to be HITRUST compliant, the SaaS company. And they come to us and say, we need to be HITRUST compliant, or at least align with HITRUST controls. Maybe we don't need to go through the full audit. What do we do? What are the steps we need to take? What are the controls we need to implement? And that is the first step to compliance maturity. Understanding what control you have to implement and what's optional is the first step. The next step is, what's the process for implementing that control? Then what's the policy and process documentation that you have for that control? Then how are we ensuring and measuring that we meet that control, right? Either automated or manually. And then how are we improving compliance over time? So on the right-hand side of the screen, you'll see this is actually the real scoring guidelines for HITRUST. When HITRUST grades you, part of 15% of your score is, do you have the policy? 20% is, do you have the process? 40% is, have you implemented the control as part of the score? 10% is if you've measured it, and 15% is if you managed it. So as you can see, HITRUST is one way to look at this, obviously, but SOC 2 has a similar type of approach in which they're basically confirming, do you have the policy? Is it measured? Is it implemented? Do you improve it over time? They may not be as structured as HITRUST in terms of points and assigning values, but the same principles apply in terms of the roadmap to compliance maturity. You may start with implementing the control and having policy documentations, but eventually you're going to need to really measure, how are you doing against that compliance control ongoing, not just point in time, the day of your audit, but how are you doing 3-6 months after your audit? So let's get an example of what this maturity sort of looks like. So multi-factor authentication. We talked about that a lot today. It's a building block of security in the cloud, right? The first question you might ask, let's say you're SOC 2, right? So a lot of you are SOC 2. First question is, what should we be doing according to SOC 2 with MFA? The answer is, we should have MFA for any user login. We should have MFA for any API operations. And we should have MFA for any access to resources with resource-based policies. Now, this little bit of code is actually representing what that might look like in an IAM policy, right? The next question is, what's the process for implementing this control? The obvious one is, we do it manually in the console. If that's your process, that's fine. That's potentially a risk that you and your auditor will identify, but that probably meets the control. Or maybe you're deploying it in something like Terraform or CloudFormation or whatever to make sure that that policy is continuously enforced. Then third, what's the process and policy? The JSON IAM document, where you actually stipulate that every user that's created has to have MFA enabled, that actual JSON document is evidence for your audit, right? Additionally, you need to have a document like in Jira Confluence or in a Word document or wherever that you actually have documented this policy and procedure. For how do we ensure or measure that we do it? The answer really here, honestly, in AWS, the easiest way to do this is AWS config, which I think we've mentioned probably 50 times today so far. There's a managed rule in AWS config called MFA enabled for IAM console access. If you enable that managed rule, you will get an alert if somebody creates a user that doesn't have MFA enabled. And your auditor will look at the fact that you have AWS enabled, you have this specific rule enabled, and say, not only are you implementing this, but you're ensuring that this control is continuously implemented, right? You're getting alerts if this is non-compliant. That's what your auditor is looking for in addition to your implementing it. And finally, how do you improve this over time? So let's say, for instance, we implement MFA in the console, which is completely fine. It works just as well, right? Maybe one of the mechanisms you identify in your audit, which is what your auditor and you will walk through, is, maybe the better way to implement this control is to create a Terraform template or a CloudFormation template that whenever a resource is created, it's automatically assigned the IAM role that gives it limited permissions or that has MFA enabled, for instance. So then, you're implementing it as infrastructure as code rather than doing it manually in the console. That process for doing that improvement is number 5 here, right? We're thinking about how to improve this over time. Okay, so what should we be doing? Let's go through some compliance frameworks, some that people have mentioned that they have to comply with. What should we actually be doing? What we should be doing depends on a lot of things. Sometimes it's a customer request. Usually a SOC 2 is based on a customer request. Maybe a lot of you guys are SaaS applications. That tends to be a lot of the requests for SOC 2 that SaaS applications get. You could have regulated data, and therefore it's actually a law that you have to comply with this framework. That's where that control would come from. Or a best practice. We get plenty of customers who come to us and say, hey, I don't actually have a compliance framework I have to meet, but I'd really like to reach for something like PCI as a standard, even though I don't have to actually comply with it or go through the audit standards. A lot of people, just as a side note, pick PCI because PCI, unlike SOC 2, PCI is extremely prescriptive. You either meet the set of controls or you don't, and you fail. So the nice part about a prescriptive set of controls, like SIS, for instance, is another prescriptive set of controls. The nice part is that it's easy to interpret, and it's easy to know what you have to do and not do, right? So let's get into it. If you are a SaaS company, like I just mentioned, or you have customers in multiple industries, it might make sense for you not to go through an independent SOC audit and an independent PCI audit and an independent HIPAA audit, but to think about, okay, what are the controls? What do we have to do across these frameworks that are common? And as you'll find, as we get into this, a lot of controls are common across cybersecurity frameworks and regulated frameworks. Basically, the same set of like 10 to 15 tools and controls is common across all of these things. So why do 3 separate reviews of your environment and audits? Why not just incorporate those all into a single multi-regulatory compliance framework? What Logicworks does, as I mentioned, we have 6 compliance frameworks that we have to comply with, right? So what we've done with our auditor, who happens to be Coalfire, is we've said, okay, how can we incorporate all of these controls into our annual high trust audit, for instance, and produce multiple reports out of that single audit. So we'll create a PCI report out of that audit, and a high trust report out of that audit, and a SOC 2 report out of that audit, et cetera, et cetera. Okay, so here is a big chart of controls, which, is probably an eyesore to look at, but it's super helpful. And I hope you guys use this when you're trying to figure out what do we actually need to do on AWS in order to be compliant with what. So let's talk about SOC because I know, and PCI, because I know a lot of you mentioned that. So essentially, all of the things that are listed here on this list: configuration management, patch management. Here's MFA again, encryption at rest, encryption in transit, a WAF, which we talked about at length on the previous session. Here's which framework that needs to comply with, and also for PCI, NIST, and CJS, what the actual regulatory control that aligns with that, right? As you can see, there's a ton of commonality across these frameworks. So again, this is getting into the multi-regulatory compliance framework. The best practice is to do all of these things that are listed here, right? Whether or not you need to comply with a specific framework or not, or whether or not your framework necessarily includes these elements. Let's talk about PCI. So here is a chart showing all of the PCI requirements, a short description, what security tool you may use, and whether Logicworks can help you as a managed service provider. So let's just go through a few examples. I'm not going to go through this whole thing. So let's talk about 10.2 and 10.6 here. So the requirement is logging and daily log review. We've talked about logging extensively here. What is actually the security tool that does daily log review? So having, as we mentioned, having CloudTrail enabled gets you part of the way to this requirement, right? You're logging stuff, good job. But the real requirement is daily log review. What does that actually mean? It actually means, like, are you doing any analysis on your log to make sure some kind of intrusion is not happening? So something like threat stack or alert logic or whatever IDS IPS tool, file integrity monitoring tool you may choose, has functionality where they're doing basically AI-based scanning of your logs to check for malicious intruders or something wrong in your logs, right? And that's a requirement for PCI. And as I said, the thing about PCI is if you meet the requirement, all the requirements you pass, and if you fail all the requirements, or you fail even one of the requirements, you fail. So that's an example of something with PCI. Let's talk about SYS. So I know one of the questions actually that we had in the previous section was about SYS benchmarks. Donovan talked through this a little bit. This, if you go to this link, I highly recommend you guys check this out. This is a very prescriptive list of control and implementations that they recommend. AWS has actually released the AWS benchmark for SYS, right? AWS and SYS, I think, collaborated on it. I think it's on version 1.3 at this time. So the question I had in the chat was, SYS just released version 8 of this benchmark. Is AWS going to catch up and release, kind of their joint foundational benchmark document? The answer to that question is, I actually don't know. We are a SYS partner, and so I could ask them and get back to you. But I expect yes. The SYS benchmarks, it depends on what changes essentially in the SYS benchmark in version 8, but likely yes. SOC 2. So this is the big one that you guys have. Unlike something like PCI, SOC 2 takes into account many, many more things in your organization than a traditional cybersecurity review, right? SOC 2 includes things like your organizational structure, whether or not you have an employee handbook, performance appraisals at your company. What's your board of directors? Do you have formal contracts or MSAs in place? Can your customers file support tickets? So these are all questions that are incidentally related to cybersecurity, right? But not perhaps directly related and not actually included in a lot of audits except for SOC 2. I will say that the process for a SOC 2 audit can be rather labor intensive and arduous because each of these things I've listed here, plus all of the controls that we've talked about previously, SOC 2 is 75% documentation and 25% implementation. So a lot of customers spend a lot of time in a SOC 2 audit just preparing and getting the documentation in order. I'd love to maybe at the end of this session, if any of you that are listening can think of maybe a couple of, if you've gone through a SOC 2 audit, maybe you can share your battle scars with the rest of the team. That'd be great to hear. Okay, stage 2, how do we implement this? So implementing compliance. So let's say you are, I'll go back to the example of the SaaS company. You're a SaaS company. You've gotten this request for high trust from an end company. You have to kind of meet these controls. Where do you even start? Where we like to start is the networking foundation. We like to start with that first. So all of the rules we went over in the first part of the segment, not having everything in public subnets, implementing bastion hosts, having default deny all rules. Those are the kinds of things we think about first. Then we turn our eyes to access. How are we turning on basic access controls? We're auditing and revoking access regularly. So this is about process, not necessarily a tool or control. Your team actually needs to sit down, look at your IAM credentials regularly and prune access for people who no longer need access, right? And as part of SOC 2, for instance, you need to remove access to people who have left your company within 24 hours, stuff like that. Step 3, when we're trying to implement controls, is we think about logging and monitoring. So CloudWatch and CloudTrail on, right? We keep talking about that. Alarms configured, centralized logging. And then step 4, we think about installing agent-based third-party tools. So IDS, IPS, file integrity monitoring, antivirus. We use Trend Micro, but obviously whatever. Egress filtering, we've talked about that, WAF. And then step 5, we think about patching, which we actually haven't discussed very much today because it's not a very sexy topic. We at Logicworks use AWS Systems Manager for patching. I'm not going to get too deep into it, but that is our preferred patching method. And the key question here we're thinking about when we're looking at an environment that's new to compliance is, do we need to rebuild this environment and migrate it over to a new target AWS environment? Because some of the things that I've just discussed, like changing the network foundation, is destructive, right? You need to terminate an instance in order to put it into a private subnet if it's in a public subnet, right? Or let's say what we have a customer right now that has SSH open to the world on all of their instances. We have to terminate that instance and bring it up in a private subnet and change the security group rules, right? Architecture diagram time. So I would like to just bring up really quick our architecture diagram for PCI. I want to show you what in real life it actually looks like to design a architecture for PCI. Just give me 2 seconds.
My favorite part of the day.
Yeah, real live architecture diagrams. Don't we love them? I'm having weird issue. Oh, there it is.
And you guys will notice that everything that we've talked about today is actually in this diagram, which is great.
Yes, exactly. Oopsie, I meant to share. I meant to present it. Can you guys see my screen? Donovan, can you see it?
Yes.
Excellent. So this is really tiny. So let's dive in. So what are we talking about here? And Donovan, jump in at any point. Okay, let's give you the general overview, right? We've got users. These are admins we're talking about. We've got a management hub VPC. We've got a network VPC or an egress VPC, as we keep talking about. And we've got a production VPC. So what I've talked about here, or what we've diagrammed here, is actually a single account with 3 VPCs in it. We can share a multi-account version of this too, but this is just for the purposes of us talking about this keeps it nice and simple. So what's actually happening from the user access level? So the users are coming in through Duo. I'm using Okta ASA, which Donovan went through, to access the Bastion host, which as you can see is in a public subnet. Now, what's this little symbol, this little, I don't know, what do you call it, Donovan, a shield? Basically what that's a shield. What that's actually representing in this diagram is that on the Bastion host and on every instance that with this shield, which the Palo Altos have them too, is actually our third-party security agents, right? So Trend Micro for us, Threat Stack are all installed as agents on the host of this instance, right? We've got this managed AD, right? And then once we gain access into the environment, all traffic is flowing through Donovan's favorite service, AWS Transit Gateway, right? So the question we had earlier was, can we just peer or have a peering connection between the management VPC and the production VPC? The answer is yes, of course you can. But once you get into dozens of VPCs or dozens of accounts, it suddenly makes a lot of architectural sense to have an AWS transit gateway, and for all the reasons that Donovan outlined. I don't know, Donovan, if you want to do another pitch for transit gateway, but lots of benefits
Yeah.
there.
Yeah, I mean, just real quick, it's a really simplified architecture here that you see the hub and spoke model between those three VPCs. If you were to do that with VPC peering, you'd need the transit VPC, and then you'd need to have a peer. You'd have to have two peers
Right.
for each VPC,
Exactly.
right? And it just becomes a lot of connections that you need. It's basically like managing a dozen VPN tunnels, With the transit gateway, you just attach them as VPC attachments, and you're good to go. It also allows you to create VPN attachments for external, like on-prem connections. So really neat service.
Exactly. Cool. So the other thing I wanted to highlight here is we kept talking about public and private subnets and what belongs in a public subnet and what belongs in a private subnet. So you can see here, we've got an application load balancer in that public subnet, and everything else is in private subnets behind the load balancer, including your RDS databases. And then over here, as you can see in the egress VPC we've talked about a lot today, here's Palo Alto virtual appliances sitting in a private subnet. All traffic from the entire environment, as you can see, is flowing into the transit gateway. And then all traffic that's destined for the internet, it gets funneled through the network VPC before it's allowed back out to the internet. So I hope that it was interesting to you guys. This is what an actual model, gold star, PCI, or actually any compliance framework diagram would look like. That kind of has all the best practices in place. And as I said, all these third-party agents, which you can't, are abstracted away by this shield, are simplified there. Cool. Stop that share, go back to my PowerPoint presentation. Cool. Donovan, you can see me?
Yep.
Okay, great. All right, let's talk about the least fun part of compliance, which is documentation, which I'm not going to talk about very much because there's not really a lot to say except that fact that you have to go away and write up a bunch of compliance documentation, which is super fun. Next step, automating, enforcing, and measuring compliance. This is where things start to get fun and interesting. So the key question we have to answer here is, we don't just want to build once on day one our infrastructure to be compliant, like, okay, yay, we built on day one and we're compliant. Whereas on day 500 and 600, we've got, resources that developers launched that don't have any of our agents installed on them. We've got resources with non-standard security groups launched. We don't want any of that stuff to happen. So how do we actually put in place guardrails to make sure that this doesn't happen? So Donovan talked about this in the control tower presentation with AWS Service Catalog. Infrastructure as code is the method to make this possible, right? What does this do? It means no Snowflake resources, no manual console launches, no manual risk of error. Now, this could be a CloudFormation template. You guys could use Terraform, which is just another infrastructure as code tool, but a little more advanced in that it's also kind of a state machine. AWS Service Catalog, which Donovan mentioned. And then we also have to talk about machine images, right? How do we actually build an image with our desired operating system and our packages and all that kind of stuff on it? Should we build a golden image, a golden AMI, where we're launching the same golden AMI every time that has maybe our application even pre-installed on that image? Or should we launch what's called a vanilla machine image, just a standard with your operating system potentially on it, and then configure that instance after launch, install our application, then install our agents, et cetera, et cetera. And that's where we start getting into conversations about configuration management, right? Because configuration management might have to do some of the work of configuring that instance after launch. So let's look at what this might potentially look like in a real life example. So here are side by side two what I called methods of image creation and configuration management. And there's no right or wrong answer to this. It's really depending on you and your application. So think of Image Factory as a tool that Logicworks has built that Donovan mentioned, but think of this as, what are we configuring in the actual machine image on the left? What belongs in the machine image versus on the right, what's qualified as Logicworks configuration management, what's actually configured post-launch. So you could have it that maybe your image has syshardening in it, your image has the latest OS patches, and your images have your latest agents in them installed in your golden image, maybe. And then after launch, what gets configured by a configuration management tool? Maybe that's initializing those agents. Maybe it's revamping or doing something with the OS based on its compute role. Maybe it's then deploying your application to that instance. All that stuff happens after the instance launches, right? Versus what's on the right-hand side, if in order to potentially speed up the process of initializing that instance and getting everything kind of ready to go and receiving code, maybe we actually move some of those role-specific component installations over to the golden image part. We'll lock that in the golden image rather than configuring it on boot. So this is getting a little bit into the weeds of what actually happens as part of the AMI versus what's happened in configuration management. And this is the core questions, some of these core questions that you're going to have to answer as you're going through what we call this compliance automation process. If we want every resource to be configured the same way, and we want every resource to have these agents and have the latest OS patches, et cetera, we have to figure out what part of the instance lifecycle does this actually happen. So here you can see that traditionally, and sorry, I just stole this diagram from some other thing I did and slapped it on the slide, but I think it's a good diagram. Your CI/CD pipeline, as you probably have, you guys all probably have lower level environments, you have some kind of CI/CD pipeline, assumes that the cloud infrastructure already exists. So whatever code commit and build process is getting deployed to some kind of test infrastructure, some kind of automated testing is happening, and then it's deployed to production. In a fully immutable, quote unquote system where everything is pre-baked, you're integrating your CI/CD and your infrastructure as code pipeline so that at certain steps, like provisioning test infrastructure and provisioning infrastructure, production infrastructure, you're not assuming that this cloud infrastructure already exists because you're building it as part of your CI/CD pipeline. So that means that this infrastructure didn't exist until a code commit occurred. Now, this is really advanced stuff, guys. I would say probably what, Donovan, 10% or less of our customers get to the point where they're truly immutable and they're launching infrastructure on a code release, right?
Yeah, I would say it's for the more advanced serverless or modernized architectures.
Yeah.
Maybe more than 10%, maybe like 20% of our customers now. But yeah, this is definitely like a fourth stage of migration, right? So we've migrated to AWS, we've got our foundation, okay, we've lifted and shifted. Stage 2, I'd say, is like optimizing and right sizing what we have. Stage 3 is like starting to refactor the app, and then stage 4 is completely fully immutable infrastructure as code, everything.
Exactly. And the reason I included this as kind of step 4 of compliance maturity is this is an advanced compliance mindset, right? Where you're actually integrating all the automation that you're doing with whatever compliance frameworks you're trying to embed, right? And so when you think about approach. If you're in the beginning of your compliance journey, you're just trying to understand, what do I need to implement, and let me manually do it in the console. And that might be fine for you. But when auditors ask you, what are you doing, not just to implement this to control, but to make sure it's continuously implemented and that no resources can ever be launched that don't have these controls in place, this would be the advanced answer. Cool. So the next I've spent a while talking about building compliant infrastructure. Let's talk about preventing configuration drift, right? So let's say you don't have an immutable system, you launched resources once, and you're just trying to maintain configuration over time. AWS config is, again, your hero in this situation, right? Enable AWS config in every region, set up managed rules, and then set up alarms based on configuration, either on a change. So they have two options. Basically, you can do it based on an immediate change, that as soon as that change happens, you receive an alert, or a periodic trigger, like notify me once a day about all the resource changes that happened with this specific resource, maybe for a lower risk resource, right? And this is where we start to get into actually automating our response to AWS config alerts, right? So it's one thing, again, to receive an AWS config alert, maybe in Slack or whatever, but it's yet another thing to actually automate the response to that alert. And that's where you're really getting into compliance as code. So you could potentially, right, create a Lambda function based on an AWS config trigger that maybe quarantines or shuts down or does something with a resource where an AWS config alert has been triggered, right? That's the next level of automation. Again, I just wanted to give you a sense of like, what does an AWS config managed rule actually look like? Here are some of the most common ones that we see we always recommend that people enable. And really it's just, this is what an alert might look like. It's telling you the time that it ran that scan, what kind of resource or resource ID it was, what rule it was running against, and whether it was compliant or not compliant. So as you can see, this compliance type where it says not compliant, that's what you generate an alert on, right? Now, what's interesting about this is you can control how how AWS config runs by tag. So let's say you guys want to tag all the resources in your environment that have PHI data in it. So that you actually tag in some way in AWS console, that resource has PHI or in CloudFormation. You can actually control how AWS config runs based on the tag. So you could run a bunch of AWS config rules in only things that have that tag and not the other resources to save on something like cost, right? Okay, so finally, we've reached the final section, improving compliance. So as I said in the beginning, this is where we're actually, so maybe we've already gone through a compliance audit, maybe we've gone through several compliance audits. Now we're really thinking, we're not just thinking about automating, but we're thinking, okay, these lower level risks that we identified maybe last year, how are we actually now addressing those lower level risks? How are we not just meeting the compliance obligation as it's written, but going above and beyond? So Logicworks, for instance, we've gone through, I really can't even name the number of audits we've gone through, but we still have some low level risks in our environment that we're kind of slowly getting through, right? They were identified, they didn't affect our audit standpoint. They weren't major effects on our security posture, but it are things that we should tackle over time as budget becomes available. And we do that over time. And then we document how we do that, et cetera, et cetera. You get the story with compliance. So that's it. That's the end of this slide share. I'm going to stop sharing and see if we have any questions about what I've talked about. I hope that was helpful, just kind of a high level overview of what compliance looks like on AWS and the specific compliance frameworks that you guys all have to meet. It looks like, Donovan, did you see any questions pop up? I'm going to pull it up.
So there's the same one from before about the SYS framework version 8. I don't remember if you addressed it already.
Yeah, I addressed it kind of in the presentation, but essentially the short answer is yes, I think AWS is going to update that. However, SIS operates on a different time scale with their benchmarks than they do with the AWS benchmarks, right? So it may be we're on, I think they just SIS AWS Foundation benchmarks released in I think that like October of 2020 was when the most 1.3 version was released. And so the 1.2 was released like a year and a half before that. So as you can see, there's not a ton of updates happening on the AWS SIS benchmark as much as SIS is updating their own foundational benchmark. So that would just be my word of caution on that. It's not going to be immediate as far as I know.
Okay. Guys, we have 2 minutes here. Does anybody have some last minute questions that you wanted to post in the chat?
Excellent. No questions? Going once, going twice? Okay. I think what I'll do then is we've reached the end of our immersion day. I hope this was helpful to you guys and you learned a lot of information. Before you run off, I would love to ask you to share I would love to get your opinion about how this immersion day has gone by giving us a survey. So I will put that in the chat. If you could answer the survey questions, that would be awesome. Or just send us feedback directly to those email addresses would be great too. But yeah, thank you so much for joining us today. And if you want to stick around to ask us any questions, feel free to do so.